In this video, we will continue practicing learning to solve a system of equations involving conics. In this particular case, we are going to be finding the intersection of a line and a circle. And we'll do it algebraically by substitution and graphically. So we'll graph the line and the circle and see where they meet. If we do it right, we should get the same answer both times. So in number 3, you see here we have the equation of a line and then the equation of a circle. You know the first one's a line because nothing is squared. When I do substitution, I like to write my equations side by side. So I've got x plus y equals 9. And then I've got the circle equation, which I'm going to go ahead and write this as x minus 3 times x minus 3, right? Because that's what x minus 3 squared means, doesn't it? And then plus y minus 3 times y minus 3 is equal to 9. Now I'm doing this out this way because in order to do the substitution well, we really need to have this in standard form without all the parentheses. So I'm going to do a double distributive property. So here I'm distributing the x, so that's going to make x squared minus 3x. And then I'm going to distribute the negative 3. So negative 3 times x is negative 3x. Negative 3 times negative 3 is positive 9. And I'm going to do the same thing with the y's. So first I distribute the y. So y times y is y squared. Y times negative 3 is negative 3y. And then I will distribute the negative 3. Negative 3 times y is negative 3y. Negative 3 times negative 3 is positive 9. And this is all equal to 9. So I do have some like terms here. So now I have x squared minus 6x, all right, I'm just putting these together, plus 9. You know, as long as I'm combining like terms, I think I'll save the 9 to put with the other 9. So looking at the y's now, I have y squared minus 6y, all right, I'm putting these together. And then now I have plus 18, all right, that's my 9 plus 9, is equal to 9. And I really need to subtract 9 from both sides. All right, so if I do minus 9, then I have x squared minus 6x plus y squared minus 6y plus 9 equals 0. So this is general form. Now I'm going to do substitution. So I need to get one of these variables by itself. I think I'll get y by itself. So I'm going to subtract x from both sides. So that's going to leave me with y equals negative x plus 9. Once I have that, I can take this and do substitution. So I'm going to put this in for y in the other equation. So that means I'm going to put it in here, and I'm going to put it in here. So first of all, I still have x squared minus 6x. But next I have y squared. So okay, for y squared, I'm going to use parentheses anytime I get ready to substitute. So then I'll have negative 6 times, and again. And then I've got that plus 9 equals 0. So I'm ready to substitute. So remember, y equals negative x plus 9. So that's what I'm going to take, and I'm going to substitute. So I have negative x plus 9. Negative x plus 9. Alright, so now I have an equation with only one variable in it. So I should be able to solve this for x, even if it takes a little time. Okay, so here I've got a binomial squared again, so I really need to work that out. So I think I'll just do that separately right now. Should I? Or should I recopy everything? You know what, maybe I'll just recopy everything. So I have x squared minus 6x plus. So this is going to have to be done twice. Now this I can go ahead and do the distributive property right now. Okay, if I take my negative 6 and distribute, that's going to give me actually positive 6x, because the negative times the negative is a positive, and negative 54. Alright, because negative 6 times 9 is negative 54. And then I've still got the plus 9 from right there, equals 0. So I just did the distributive property. Now, meanwhile, back at the ranch, I've got this negative x plus 9 times negative x plus 9. So I need to do that double distributive property. So I'm going to distribute the negative x. So that's going to give me positive x squared, because a negative times a negative is positive. Now negative x times 9 is going to be negative 9x. Then I'm going to do the distributive property with the 9. 9 times negative x is again negative 9x. 9 times 9 is 81. So that's what you get when you multiply this binomial out. So I'm just going to bring down everything else. So I have x squared minus 6x plus all of this plus 6x minus 54 plus 9 equals 0. So now that I've got no more parentheses, it's time to combine like terms. So for example, I've got this x squared and this x squared. I don't see any other x squared, so I'll put that together. So that will make 2x squared. Alright, what other like terms do we have? How about x terms? So I have negative 6x and negative 9x and negative 9x and positive 6x. I've got all those. Well, look, the negative 6x and the positive 6x, those just cancel each other out. So all I really have is the two negative 9x's. So together they make negative 18x. Okay, so that's my x terms. Now how about my constant terms? Alright, I'm talking about the 81, the negative 54, and the positive 9. So what's that you say? It was 81, negative 54, and positive 9. Hold on, it's off camera. So that gives you 36. Alright, so I've got plus 36 equals 0. Now, ultimately, I will need to either factor this or use the quadratic formula. However, all of these are divisible by 2. So why not make your life easier and divide everything by 2 first? If you do that, then you're going to get x squared minus 9x plus 18 is equal to 0. Okay, so I want to go ahead and try to factor this. So maybe this will factor as a binomial times a binomial. Let's try. X squared is x times x. Looking at the 18, one possibility is 3 times 6. 3 times 6 is 18. Or it could be 2 times 9, because that makes 18. Or it could be 1 times 18. I need the outer plus the inner to make the middle, which is -9. So that means my best bet is the 3 and the 6. All right, so if I put the 3 here and the 6 here, for example, inner, I have 3x. Outer, I have 6x. Together, they must make -9. That will happen if these were both negative, like this. And that will work out because a negative times a negative is a positive. So -3 times -6 is positive 18. So that is the correct factorization. Now, to get my actual solutions, the x values, I need to take these two factors and set them equal to 0. Okay, so x minus 3 equals 0. That'll give me one solution. And x minus 6 equals 0 will give me another solution. So here I would add 3 to both sides. And here I would add 6 to both sides. And that's going to give me x equals 3. And this will give me x equals 6. So these are my two x values, 3 and 6. But I need to find the y values that go with them. And the way I'm going to do that is using this equation right here. So I like to make a table of values when I do this. So I'm dealing with x's and y's in my table. All right, what were those x's again? 3 and 6? Yeah, 3 and 6. So I have the x values, which are 3 and 6. I just need the y values that go with them. Okay, well, I know the y values will be -x plus 9. So in this case, all right, -x plus 9, that would make -3 plus 9. But that would be 6. And in this case, -x plus 9, that would make -6 plus 9. That's going to make 3. All right, so what I'm seeing is we have these two solutions, 3, 6 and 6, 3. So that is how you solve a system algebraically when you are dealing with a circle and a line. Now, let's solve it graphically, and it will actually be much easier, but you need to know both. To solve this graphically, we need to graph the line and the circle and see where they actually meet. I'm going to use this version of the line, y equals -x plus 9. It's called slope-intercept form. In this form, this is your y-intercept right here at the end. So 9 is my y-intercept. So I could come up here and put a dot right on the 9, and that's where my line will start. Then the slope is -1. In fact, I can think of it as -1 over 1. So I'm going to go, because of that, down 1, right 1. Okay, so starting from here, down 1, right 1, down 1, right 1, down 1, right 1. Again, repeat, 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 repeat. Okay, so this shows us where our line is. And, go ahead and connect those dots. Okay, so that's our line. Now we need to also graph the circle. And I will use the original form they gave us, the standard form, to help me graph the circle. Looking at this equation, we should be able to tell the center and the radius. The center is going to be 3, 3. The opposite of this and the opposite of that. The radius is going to be 3 because this is the radius squared, so you take the square root. So let's graph that circle. All right, with center 3, 3. All right, the center is going to be right here. Now with a radius of 3, that means I'm going to go up 3, down 3, left 3, and right 3. So you can already see the 2 points where the circle is going to be touching, but let's go ahead and draw the circle. Okay, so there's your circle. So you can clearly see the intersection points are this point right here and this point right here. And so the coordinates are 3, 6 for this point, and this one is 6, 3. So how do those match up with the points that we found algebraically? Oh, look at that. 3, 6 and 6, 3. Same exact thing. All right, but that is how you would solve a system involving conics graphically, or really any system graphically. You will just graph both shapes and look for the points of intersection. All right, guys, that was a long, tedious problem, but here endeth the lesson.